Okay, so I was asked to do the splitting fractions involving the trig functions on video so that I could explain it a little bit more deeply, and that's fine. I have no problem doing that. So the splitting fractions technique, you actually do as it is, do as it says, split the fractions off into pieces and evaluate them as two separate integrals. So let's see what we have here. Okay, so the first one we're going to pull off and break it apart. Okay, and notice that this is tangent and this is secant. So if I integrate that, taking the antiderivative, that's just secant t. So that one was pretty straightforward. This one, we're going to take advantage of a substitution to be made, and that is we're going to substitute for tangent sine over cosine. Okay, so when we do that, we get sine over cosine over cosine, and algebraically reduce that, you get sine over cosine cubed t dt. And whenever you're doing these problems, you should ask yourself along the way, could there possibly be a u substitution at any point? And we can let u equal to cosine of t, and du is going to be minus sine t dt. So making that substitution, right, that's going to be equal to minus, I have to pull out that minus sign because there's a minus sign here. Okay, and it's 1 over u cubed dt. So I'm just going to rewrite that with a negative exponent so that I can easily use the power rule. And that's going to simplify to, or the antiderivative is going to be u to the negative 2 over 2. And back substitute, you get 1 over 2 cosine squared t. So let's put both of those pieces back together. And this integral is equal to secant t plus 1 over 2 cosine squared t plus a constant. And really just by convention, it's nice if you can get everything in terms of one trig function. In this case, it's very easy to do that because we can substitute secant in. So this is 1/2 secant squared t plus a constant. So I hope seeing this in video with the two different approaches for the split integral will help you. That's it.